Hello everyone, in this video I'm going to be talking about the difference between series and parallel circuits. Now this isn't an intro really to circuit symbols and diagrams. I'm going to do another video explaining what the different symbols etc. that I'm going to use are. So in this I'm going to just presume that we're comfortable with those symbols. I'm just going to highlight the key differences between a series circuit and a parallel circuit in terms of current and voltage and how they vary, and we'll talk about what they are included in this. So the first thing we're going to do is draw a very basic circuit. So I'm going to draw this here. Now what I'm going to do is draw them. Now you should really, when you're drawing this in school, draw this with a pencil and a ruler. This program here doesn't give me the ability to just draw straight lines, so I'm sorry if it looks a little bit wonky. But what we've got here is a basic circuit. We'll label these few parts. So we've got a cell here, which is going to provide our power. We've got some electrical wires here, and this is the symbol for a bulb. Now the question you might get asked, has the bulb lit? So what we're going to do is I'm going to work through a series of questions, the questions I work through with my students to explain series and parallel. So if the question is, has the bulb lit? The answer would be yes. So we'd have a tick because the bulb has lit in this instance. So what we're going to do now is build this up. We're going to put a second bulb into the circuit. So I'm going to do this in blue. We're going to add a second bulb here. So I'm going to need to knock out some of the wire. And in blue we'll put in a second bulb. And the question you might get asked is, how bright is the first bulb now? And you should find, so in this example, how bright is the first bulb? You should find that it goes dimmer. So dimmer would be an answer here. So I'm going to do this, work through this video as a series of questions and answers with it. So it would go dimmer. Let's explain why. Now, an ammeter is used to measure current. Current is the flow of the electrons in the circuit and is measured in amps. So what we're going to do is we're going to make a note of that first of all. So current, it's the flow of electrons in the circuit. So flow of electrons in the circuit. And it's measured in what we're called amps, A-M-P-S, and we use an ammeter. So we're going to put an ammeter into this circuit above, and an ammeter is written as an A with a circle round. So we'll just put an ammeter in there. Now let's imagine we need a reading for current. So let's say that comes out as 5 amps. I'm just making up a number here. So 5 amps. If we put an ammeter on the other side of this circuit, so let's say we put an ammeter where I've put an asterisk in purple. Let's say I put one over here. Then what we should find is that the reading should also be 5 amps. So let's see what that actually means, what we can gauge from that there. What we've made is a series circuit, so it's almost like one loop from the cell here. So this is a series circuit, and in a series circuit, the current, so the flow of electrons, is the same at any point. That's the key thing here. So the current is the same at any point. So if I move the ammeter to where it was at point 1 to point 2, if I put it at 3, point 4, wherever I put that ammeter, the current stays the same. So that's one thing to note about a series circuit, that the current is the same at any point. In a series circuit, however, the voltage is divided between all of the components equally, so the voltage isn't the same. So let's think about that. So we're going to reduce this down, we'll put that up here. Let's draw another circuit here. Let's put a bulb in place. So here's our circuit that we're working towards. And what we're going to use now is a voltmeter, which measures voltage. And that's the force or the push given by the battery or cell to the electrons. So we're now going to consider voltage. Voltage is the push or force given to those electrons. Force given to the electrons. And it's measured in something called volts. V-O-L-T-S. And we're going to use a piece of equipment called a voltmeter. So we need to attach a voltmeter to the circuit, and it's done like so. The voltmeter goes, in fact, let's just get rid of the middle part there. The voltmeter goes around an electrical component, so we put it around the bulb. So we're going to attach the voltmeter, and let's think what the reading on a voltmeter could be. Again, I'm just making up a number, complete made up number. Let's say this is 1.5 volts. I'm just plucking a number out of my head here. Let's say it's 1.5 volts. If we were to put two bulbs into the circuit, so now let's clear a bit of room here, and let's put in a second bulb into this circuit. You should notice that the voltage goes down. In fact, it goes down by half, especially if the bulbs are the same type. Now, what that implies is that the voltage is divided between all of those bulbs equally. So if we have a voltage of 1.5 volts when we have one bulb, when we have two, each one would now show as 0.75 volts if we were to put a voltmeter on both bulbs. So they actually share voltage. So this is one key difference between a series and a parallel circuit. In a series circuit, and we're coming on to parallel, but in a series circuit, the current is the same all the way around, but the voltage is divided equally between all of the bulbs, all of the components. So I'll put a little note at the top. So in a series circuit, current remains equal at every point around the circuit, whereas the voltage gets divided up equally between each component. So that's something that defines our series circuit. Now what I usually get my students to do is to make the parallel circuit. So again, we'll just shrink this down, and I'm gonna try and keep this all on the one slide so it's easier to compare. So let's make a parallel circuit. Now we're going to need a cell again. We'll have a bulb. So same setup, cell, wire, electrical wire and a bulb. But in a parallel circuit, we don't put bulbs next to each other in the same loop, if you like, but instead we have them in parallel in another loop. So another bulb in parallel would look a bit like this. That's what a parallel circuit would look like. So we have bulb 1 in one sort of loop, if you like, and bulb 2 in another. I'm going to call it a loop, but it means it's in a parallel circuit. So what we were looking at before was series, now we're starting to look at a parallel circuit. Now, in a parallel circuit, once it's set up like this, I want you to imagine 4 particular points on this circuit, A, B, C and D. Let's say point A is here. Let's imagine B is right there next to the bulb. C is here and D is there. And we're going to put an ammeter in the circuit at points A, B, C and D and record the reading for current. Now what you should find is something quite interesting, because in a series circuit I said current is the same no matter where you put it, but that doesn't apply in a parallel circuit. If we imagine the current at A being, let's say, 5 amps, what you'll notice is that at B, that would be 2.5 amps. And at C, equally, that would be 2.5 amps. If we were to move our ammeter, so we put 1 ammeter in and we move it from position to position and put it at D we would get a reading of 5 amps. Now that implies something really significant. In a parallel circuit, it's the current that is split equally across each loop. But it's always the start, or the same, it's always the same at the start and at the end of the circuit. So A and D would be the same, B and C would be the same. So just to reiterate, in a series circuit, the current is the same all the way around. It's equal at every part. In a parallel circuit, the current is split equally across each loop, but is always the same at the start and the end of the circuit. In fact, I've just noticed at the top I wrote, if we go back to the very top right corner where I put current equals equal, I really should have wrote everywhere, because that's the key bit I'm trying to highlight now. So I said that the voltage was divided equally across each component. The current is equal everywhere. And that's contrasting to this parallel circuit, because in a parallel circuit, the current isn't equal everywhere. It gets split across each loop to each component, but then is the same at the start and at the end. Now, if we were to take a voltmeter, and I'm going to draw this in green, if we were to take a voltmeter and put a voltmeter across this first bulb, bulb 1, and we get a reading of, say, let's say our V1, our first voltage comes out as 1.5 volts, let's say. If we were to move that and put it across the second bulb in this, so that was the one in the sort of second loop around bulb 2, what we'd see is that V2 is also 1.5 volts. So the voltage actually stays the same across each bulb in a parallel circuit, completely contrasting series. So in a series circuit, the voltage was divided equally across each component. In a parallel circuit, the voltage stays the same across each component. So just summarize that, like I did with the series circuit at the top, I'm just going to put a little note down here about in parallel. So in parallel, what you find is that the current splits equally across each component. And by component, I mean a bulb in this example. Whereas the voltage in a parallel circuit stays the same. So I could just write, like I did at the top right, equal everywhere. So 0.5 volts or 1.5 volts across bulb 1, 1.5 volts across bulb 2, so it's equal across each component. They are the key differences between a series and a parallel circuit. In a series, current is equal everywhere that you were to put an ammeter, voltage divided equally across all the components. In a parallel circuit, it's the voltage that is equal everywhere and stays the same across components, and it's the current that splits equally across each loop. Okay, hope all that helps.